rogue planets, planets that are not connected to stars and are found wandering around. Most of the planets in the galaxy may be of this kind. In the face of this amazing and expanding diversity, we must abandon our outdated theories about how planetary systems form and acknowledge that many different kinds of systems could exist. Put another way, we need to create new paradigms to handle the information we are discovering about exoplanets. We have concluded that the intense focus on the Goldilocks planet was misplaced in light of the expanding list of strange worlds. The Goldilocks planet, like Earth, is a hypothetical body close to its star, which means it is not too hot, not too cold, but just right. By just right, we mean that its surface can support oceans of liquid water. Naturally, this focus is because we might anticipate a similar life in such a world. How about life? This leads us to the question that most excite people about exoplanets. Are any of these new worlds habitable? But when considering that life exists, we must admit that the single example's curse strikes once more. Only one kind of life, the outcome of a single experiment, is known to us. Every living thing on Earth is descended from a single first cell and functions using the same genetic code and fundamental DNA structure at the molecular level. You may be surprised to learn how many molecules you and lawngrass share. We approach the question of life with the presumption that whatever we discover there, if anything, will be like us in some way, just as we did when we first started investigating the world of exoplanets. Like shifting gears in a car, life on Earth may have originated in two stages. The first stage involved creating the first living cell from inorganic materials. The second stage involved the process by which that first cell gave rise to the variety of living forms that we currently observe. The evolution of life on Earth after the first cell appeared is largely explained by the theory of evolution. Intensive research is being conducted to fill in the blanks about the development of that first cell. Earth was a rather dull place for the next 3 billion years, after life first appeared on our planet 3.5 billion years ago. Therefore, an alien visitor to Earth would have discovered a planet with green pond scum in its oceans. Intelligence and technology emerged much later, and complex multi-celled life only emerged in the last half-billion years. Indeed, it is likely that the exoplanet where life is found will be a pond scum planet. According to the dominant paradigm, any life we find will be carbon-based and function similarly to life on Earth, albeit perhaps not using the same molecules. If molecular chemistry is the foundation of life on Earth, genetic information must be passed down from generation to generation via a molecular mechanism like DNA. Some contend that carbon chains must be involved, since such a molecule must be big and intricate. We are looking for the Goldilocks planet because carbon chemistry moves quickly in liquid water. Despite concentrating only on molecular life, the diversity and abundance of exoplanets suggest that we should expect surprising patterns not seen on Earth. For example, plate tectonics drives Earth's natural selection and evolution pattern by continuously changing the planet's geography and ecosystems. This implies that living things always catch up and adjust to their new surroundings. For instance, early humans may have developed upright posture and intelligence due to the drying up of rainforests in north-central Africa millions of years ago. But we can wonder what evolution would be like if no surface changed all the time. Was it going to stop? Would such a world exhibit the evolution of complexity observed in Earth's fossil record? Would technology and intelligence change? The variety of exoplanets contains the answers to these kinds of questions. We can also delve deeper. Does molecular chemistry have to be the foundation of life? Like on Earth, does it need to evolve through natural selection? On average, life scientists. In Chapter 12, we suggest that just as we needed a new paradigm to deal with exoplanets, we will need a new paradigm to deal with life. A paradigm that inevitably takes us away from the Goldilocks planet and towards something much richer and more exciting. We argue that this may not be the case and attempt to expand our imaginations by speculating about the possibility of entities that are, arguably, alive, but not like us. The Fermi paradox is an old question raised by the planet's amazing diversity. It is named for the Italian-American physicist Enrico Fermi, 1901 to 54, who raised the straightforward question, where is everybody, in response to a claim that the galaxy should be teeming with highly developed technological civilizations. Given the vast world we know exists, why do we appear alone? Ultimately, this may be our new galaxy knowledge's most significant query. Our solar system would naturally be the first area people would look at when they looked up at the sky. Since the moon and our sister planets are closer to us than anything else in the sky, they are, in astronomical terms, our neighbors. What prevented us from looking into them first? The beginnings of human understanding of the solar system are obscured by the haze of antiquity. Monuments like Stonehenge demonstrate how people who lacked a written language and, in fact, metal tools were able to have a startlingly detailed understanding of how the sun, moon, and planets moved. We know that most ancient societies knew about the planets. The Greeks, for instance, attributed each to a crystal sphere in the sky, and the Mayan number system might have been influenced by Venus's appearances and disappearances. Galileo Galilei, 1564-1642, did not turn a telescope to the sky until 1609, when he saw the first of many paradigm-shifting revelations. Galileo probably learned cosmology from the ancient Greek philosophers, who taught it in universities during his time. According to this cosmology, everything in the heavens was flawless and unchanging once we left Earth, the immobile center of creation, where change and decay were present. According to Galileo's paradigm, the sun must be a perfect spherical ball of fire, and the moon must be a perfect crystalline sphere. He didn't see that, though. He observed several blemishes on the sun that we would call sunspots, or more likely, sunspot groups, and mountains, craters, and other imperfections on the moon. What's most telling is that he observed 4 stars, his term, orbiting the enormous planet Jupiter. His data indicated that some objects appeared to be quite content to orbit Jupiter, despite his paradigm telling him that everything in the heavens had to circle Earth. To gain favor with the court, Galileo referred to these bodies as the Medicean stars. His success was demonstrated when he was appointed to a position in the Florence court of the Medicis, now known as the Galilean Moons. Under the title Sidereus Nuncius, Starry Messenger, Galileo published his findings in 1610. The fact that the book, basically a list of his telescope observations, created such a stir may seem odd to a modern reader. But the book made him enemies who would later try him for heresy for a later book, because he wrote in Italian and was reaching the educated people outside the church. We should note that Galileo's harsh demeanor likely did not make him many friends, but we don't have time to delve into that somewhat complicated tale here. In any event, theories concerning life elsewhere in our solar system emerged more quickly after the new Copernican idea of heliocentrism was accepted. Today, we find some of the early ideas about aliens to be rather odd. For instance, several serious astronomers in the 18th century suggested that life existed on the sun, in the presumably cooler interior, not on the blazing outer surface. Some even attempted to view farms and villages below, using their telescopes to look through sunspots. In his book Celestial Scenery, or The Wonders of the Planetary System Displayed, illustrating the perfections of deity and a plurality of worlds, published in 1837, English country parson Thomas Dick boldly predicted that 8,141 963,126,080 people would reside on Saturn's rings. The book's tone implies that the learned cleric expected the residents to be Englishmen. Nearby worlds, such as the Moon, Mars, and Venus, became the focus of thoughts about aliens as the 19th century transitioned into the 20th. The idea that the Moon was inhabited was nearly universal. In fact, in 1901, in 1946, G. Wells published The First Men in the Moon. The American astronomer Percival Lowell, 1855-1916, published the first of 3 books about the planet Mars in 1895, titled Mars, 1895, Mars and Its Canals, 1906, and Mars as the Abode of Life, 1908, in which he detailed his observations of the red planet. In this book, earthly visitors explore the lunar surface without spacesuits and come across a technologically advanced race of Selenites. He paints a picture of a highly developed society on Mars in these books, one that constructed an intricate system of canals to transport water from the poles to the arid equator.